It's great to be here at a new venue this year after I think 7 years of doing it in Brussels. I've really enjoyed it so far, as usual. We can meet with all of the key influencers that we want to meet at our customers, the Tier 1 manufacturers that provide into the automotive industry, and also the OEMs. The reason we're here is to showcase our latest and greatest technology. So we'll be talking about some of our new Hyperlux image sensors and some of the ecosystem activities we have around that. We're also showcasing a new demo for our LiDAR depth sensing solution, as well as a depth sensing solution for in-cabin applications. So a host of different things that are new since we last demoed here, both last year and in the Detroit version of AutoSens. First, we have on my right, we have the Hyperlux image sensor and partner ecosystem. So we have our 8 megapixel and 3 megapixel image sensors, which are tuned on a couple of partner platforms from ARM and from NVIDIA. So the image sensor output goes into the processor from each of those companies, and we're showing that this is the best image sensor for high dynamic range and LED flicker mitigation, and it's supported by our partner ISPs, which is really important for the automotive ecosystem because not every Tier 1 manufacturer and OEM has the same architecture. So it's important for us to say our sensor, which has the best sensor technology and pixel technology, is supported by these vendors that make the SoC chips that have the image signal processor on them. We're also showing behind me a new demo, which is actually a mass production LiDAR made by a company called unveils. So their product was just announced to be in the BMW 7 Series, enabling their personal pilot feature, which allows true level 3 eyes-off autonomous driving, which means the driver in certain situations on certain roads does not have to be paying attention to the road. And that's enabled by, of course, image sensors and cameras, but also the existence of a LiDAR, which enables depth sensing. And it's intended in a front-facing automotive application where you're able to see up to 250 meters and detect small objects, low reflectivity objects on the road. We're also on my left showing depth sensing application for in-cabin. So this is using onsemi smart indirect time of flight technology. In this case, we've taken our depth sensing technology, implemented on an image sensor, and integrated it into a module working with one of our module partners called Quanta. It's integrated into a module for driver and occupant monitoring, which means that inside the cabin, you have an image sensor which is able to show you what's going on with both the driver and the occupant. But importantly, we're showcasing a new technology, which is that not only are you getting a 2D image from the image sensor, but it also is able to give you a depth image in parallel. So you see a point cloud in addition to having the 2D image. And we've been having a lot of people go up to the booth, and we can showcase that later, where you stand in front of the demo and then you see some of the different features that it enables, like smart airbag detection. In some cases, if the driver is too close to the steering wheel, you don't want to actually deploy the airbag, for example. And depth sensing allows you to get a precise estimate of where the driver is at, rather than just relying on a 2D image and estimations. We have a partner company named SmartEye, which is running their driver monitoring algorithms on their software algorithms running with the output of the camera module that I mentioned, where they take advantage of both the 2D image output and the simultaneous depth output of onsemi's smart indirect time of flight technology. That's a great question. So with our Hyperlux image sensors, what we've tried to focus on is these sensors are used in mission critical systems. So advanced driver assistance systems that enable features like automatic emergency braking and forward collision warning and lane keeping assist. These are really things that save lives. And what we've done in terms of innovations on our image sensors is we've pushed the technology to enable higher dynamic range in a single exposure. What that means to a layman is if you imagine you're driving through a tunnel and you're coming out of it, even your eyes are going to be adjusted to the dark scene, and as you're coming out of the tunnel, you may not be able to see all the detail outside. Our image sensors can actually see better than the human eye in terms of the dynamic range that they can capture. And with Hyperlux, what we're allowing to happen is using a single photodiode pixel on these sensors, we're able to capture 120 dB of dynamic range to capture all of the bright parts of the scene in addition to the dark parts of the scene without any motion artifacts and without any pulsed LED artifacts, which may be due to headlights or taillights or traffic signs where the LEDs are pulsing on and off. And you would basically capture all of that detail simultaneously in a single exposure. And that means that you can have a safer autonomous driving or ADAS system because you're not going to have motion artifacts from frame to frame when you're capturing these scenes. And you're also not going to lose lane markings because you're coming out of a tunnel and it's a bright environment and you are enabling a long exposure to see the dark areas. You're able to capture the dark and the bright at the same time. In addition to that, of course, our silicon photomultiplier technology, which is used in LiDAR, which is used in this NVIDIA one that I was talking about earlier, allows you to capture single photons that are detected in near infrared 905 nanometer LiDAR. So a company like NVIDIA has taken our sensor technology, our silicon photomultiplier, and because we've enabled this high sensitivity, single photon sensitivity with our silicon photomultiplier arrays, they've been able to integrate a solution that can enable autonomous driving on the highway without the need to make sure the driver is able to take over. So that's a really key feature as well that, again, helps to save lives and adds convenience features to drivers. One of the things that I didn't mention earlier that's also important is low light sensitivity. Cameras need to be able to see, because they're the eyes of the system, at extremely low levels of light. So you've got your headlights, of course, but you'll have a lot of environments where you need to be able to see hundreds of meters ahead of the vehicle in order to be able to safely stop. And you have environments where you're less than 1 lux, even 0.1 lux of light level coming back onto the sensor. And so you can think of having a tire down the freeway that you need to be able to detect. So being able to see at low light is important. What is onsemi doing for that? Well, we've pioneered our super exposure pixel technology that's on our Hyperlux image sensors, which succeeds our Hayabusa image sensors that we released to the market years ago. And this is all with the intent of using a single photodiode while providing the high dynamic range. The reason a single photodiode per pixel is important is if you get the dynamic range from having multiple photodiodes and multiple captures per pixel, you're really trading off area where you could be capturing photons of light. And that means that you're going to have a less sensitive image sensor for the same area. So that's one of the key things that we've been focused on for the last 7+ years, and we're iterating on those, and we have future developments as well that will build on this technology. One of the things that onsemi did that I talked about at AutoSens Detroit was we wanted to take a different approach to interior sensing and in-cabin applications rather than just increasing the number of megapixels you have on these image sensors that are used in-cabin for interior sensing. The thing that our customers are trying to enable is you need an interior sensing camera to be able to detect the driver's gaze, the driver's attention, and you also want to be able to detect occupants. And all of these are with the intent to aid the ADAS system to be less responsive or more responsive based on the driver's gaze, or to just warn the driver if they're distracted. And so our approach is inventing a novel pixel technology, which not only gives you the ability to do that with a global shutter image sensor, but also enabling depth sensing. So I mentioned earlier some of the benefits of depth sensing. Depth removes ambiguity, so you can't, if you're using the interior sensing camera for driver authentication, you can't hold up a photo of a person and spoof the system. But also the safety critical features, as I mentioned, like being able to precisely see where the driver is for smart airbag deployment, as well as the passenger. Those are things that we've been pushing the messaging of depth sensing is important for in-cabin. And for applications which in some markets are starting to come about for in-cabin, which are more for infotainment, like selfies and video conferencing, which are not so safety critical, we can actually enable that with a separate camera that does RGB, and we can really focus the interior driver and occupant monitoring sensor to have both a 2D and a 3D image with our indirect time of flight depth sensing technology. So what we're showing today that we weren't showing in Detroit is we took that depth sensing technology and we've integrated it into an actual form factor module for driver and occupant monitoring that can be mounted into the rear view camera and be able to detect both the driver and the passenger and give you the 2D depth and a 3D output simultaneously. In Detroit, we talked about this technology. I gave a talk on that, but in addition to that, we were showing just the engineering level output of that system. Now we have it in a form factor module so that when our customers come by and take a look at the demo, they see really what it's able to do. And we worked with our partner company, SmartEye, to implement their next generation algorithms. They took this module and they calibrated it and for the use case, and they added their latest algorithms on there.